and there's a particle dangling from the uniform electric field that has some charge Q. It says find out what, and it has a charge Q and a mass M. It says find theta, right? So the easiest way to do this is to say, well, I want to find, I can do the sum of the forces on this is equal to 0 to get everything I need. So if I draw a free body diagram on this charge, there's mg down. There's going to be a force of tension here due to the string, where this is theta. And then the electric field is exerting a force this way. And the force of the electric field is just Q times E. So from this free body diagram, I'm going to use that sum of the forces in the x direction is equal to 0. So the two forces in the x direction is there's going to be the electric force that way and a component of the tension that way. So the electric force is minus QE, and the force that way is going to be a component of the tension, which I believe works out to be T sine theta. Now I want to find theta. I don't really care about T. I can also do the sum of the forces in the y is equal to 0. So force downwards minus mg. Force upwards is the component of the tension. Remember, I can break the tension into two components here, Ty, Tx. And so this is going to be T cosine theta. And then I can use these two equations to solve for theta. So I can just see, I can write we'll call this equation 1 and this equation 2. So equation 1 becomes T sine theta equals QE. Equation 2 becomes T cosine theta equals mg. I divide those by each other and I end up with tan theta is equal to QE over mg. There, I've solved for theta. So theta is going to be equal to the